For number 3, the question says the depth of seawater at a location can be modeled by the function h that satisfies this differential equation. Now, h of t is measured in feet, and t is measured in hours after noon, where that is t equals 0. Now, it is known that h of 0 equals 4, so that means the depth of seawater is, at noon, is 4 feet. Now, they tell us that h of t is dependent on time, okay? So we have our slope field here. And now, it says, sketch the solution curve y equals h of t through the portion 0.04. So they give us the 0.04. So what we want to do is we want to go with the flow. So that means it goes up, kind of crests here, and then it starts to fall. And so that's really what they're looking for. They're looking for us to start here at this point, and as we go with the flow, it goes up, hits a maximum around 3, and then goes down. Now in part B, it says for 0 less than t less than 5, so we're in this interval from 0 to 5, it can be shown that h of t is greater than 1. So first thing is we want to find the value of t for which 0 less than t less than 5 on that interval, at which h has a critical point. All right. So, a critical point is when the derivative equals 0 or is undefined. Now, when I look at this differential equation up here, h minus 1, well, h is always going to be defined, so it's never going to be that's never going to be undefined. And cosine of t over 2, that's always going to be defined for these values. So I don't have to worry about it being undefined. All I have to worry about is dh dt equals 0. So that is 1/2 h minus 1 times cosine of t over 2. Now, important thing here is they tell us this piece right here, that h of t is greater than 1. So what that means is that this right here is always going to be positive. Well, 1/2 is also always positive. So if this whole thing equals 0, and this is positive and this is positive, the only part that could be 0 is the cosine right here. So I can pretty much just ignore all that other stuff and just say 0 equals cosine of t over 2. Now cosine is 0, if we think about our unit circle, at 2 points, at pi over 2 and 3 pi over 2. And usually we only have to concern ourselves with those two values for the non-calculator portion. So that means we have pi equals t. We also have 3 pi equals t. Now they give us this restriction for 0 is less than t is less than 5. So 3 pi is just way too big. So the value of t that we're looking for is pi. So that's when it happens. And if you look back to part A, you can see that it kind of agrees. The maximum occurs right around 3, a little past 3, so about pi. And then it says we want to determine whether it corresponds to a relative maximum, relative minimum, or neither. And we need to justify. Now, we could just try and use the eyeball test, but that's not an adequate justification, unfortunately. So the question is, how do we justify if something is a max or a min? Well, what we have to do there is we have to use the second derivative test. So I need to find the second derivative of this equation. Now, this is going to require product rule. So the derivative of the first part, that's going to be dh dt. Then I'm going to leave cosine alone. Then I'm going to leave h minus 1 alone. Then I'm going to find the derivative, and this is going to be negative 1/2 sine t over 2, like that. And now I want to plug in this point. So what do I know about this point? Well, at this point, h is greater than 1. So that means I know that this is positive. But what else do I know? I know that t equals pi. Well, if I plug in pi over 2 here, I know that this is going to equal 0, and this is going to equal 1. So I don't have to worry about the rest of this first term here because it's going to be zeroed out. So I'm left with 1/2 times a positive times negative 1/2. So I have negative 1/4 times h minus 1. And the key thing here is that this is less than 0. What value is it? I don't know what the actual h value is, but that's not important. What we know is that it's positive times a negative means this is negative. So what does this tell us? This tells us that the concavity is negative. So that means it's concave down. And so when things are concave down, we have a maximum point. So the way we justify this is the critical point at t equals pi is a relative, and we have to say relative, maximum, because the second derivative, d2h dt squared, is less than 0 at that point for 0 less than t less than 5. I should say for... No, we already said for t equals 0 at that point where h is greater than 1. Should probably mention that detail because that is the detail that allows us to say that this is a positive right there. Okay, so that was part B. So now part C, it says use separation of variables to find y equals h of t, the particular solution to this differential equation. So with my students, I always say separate, integrate, isolate. Those are the 3 steps. So the first step is separate. So I have 1 over h minus 1 dh. And I like to leave the 1 over h minus 1 separate from the dh. College Board likes to put the dh on top. I prefer to keep it separate just so you can see why ln shows up the way it does. Okay, so that's, we separate. So now we integrate. So this is going to be ln of h minus 1 equals, and this is going to be sine of t over 2 plus c. Now for this side, if you think it's necessary, you can do the u substitution. U equals t over 2. So that means du dt equals 1/2. So then du equals 1/2 dt. And so that means when you make that substitution, you get cosine of u du, which then becomes, sine of u plus c. Okay. Now, since we know we have the initial condition that h of 0 equals 4, the absolute value is a bit of a moot point. And they're not going to, the College Board's not going to take points off for that if you don't need it. All right, so now, I'll call that C1, I'll call that C2. And h equals C2 e the sine of t over 2 plus 1. So now, if I want to find the particular solution, now I've got my general, so now I plug in 4 in for h, and I have C2 e to the sine of 0 plus 1. So sine of 0, if I think of my unit circle, that's the y value right there, so that's 0 plus 1. So anything to the 0 power is 1. So that means 3 equals C2. So that's our constant. So h equals, and we should probably not just say h, we should probably say h of t, because it's a function of t, 3e to the sine t over 2 plus 1. And there we are. There's our solution. All right, we'll see you in the next problem.